Hello everyone, this is Dr. Kalpana and you're watching my YouTube channel Pharmacy Lessons Made Easy. The topic that I have chosen for this particular video is related to elasticity and Newton's law of fluidity. The reason for choosing this particular topic is in pharmaceutical technology, basically we carry out rheological measurements such as mixing of material, filling, packaging. If we are trying to pour something from bottle, like extrusion of ointment from a tube, or we are using atomizers for spraying the liquids, or something has to be released from syringe needles. Every particular fluid has to change its shape, or in other words it has to deform itself. That's why rheology came into picture. Rheos actually is a Greek term which was modified by adding logos, and the term rheology came up. Rheos means flow and logos means science. So particularly rheology is a term which is used to study the deformation or flow of matter under the influence of particular stress. So after applying the stress, the fluids get deformed, and that is why we are able to pack them, we are able to apply them on skin, we are able to take ointments, pastes, etc. from their tubes, we are able to atomize or spray the liquids where we need rapid action. We are able to stabilize suspensions, emulsions, and semi-solids because their physical stability is dependent on their rheological properties. Viscosity also affects the bioavailability of the drugs, as we already know. Moreover, any drug, if has to be released from its dosage form, like tablet, capsule, or novel drug delivery system, the deformation of matter comes into picture. So that's why I've chosen this particular topic. It is related to the rheology. First, understand the term elastic deformation. It is actually based on Hooke's law of elasticity. The deformation of matter under the influence of force or stress can be described by two particular components. First is your elasticity and second is viscosity. If we talk about elasticity, it can be achieved if we try to change the shape of any body. It if get restored once the force is withdrawn, like the case I have shown you in this particular spring as an example, is an example of elastic behavior. So it is actually the property of solid materials, and Hooke's law is used to describe the elastic deformation of solids. Hooke's law of elasticity says that stress is directly proportional to strain. The body actually get reformed into its original shape and original size once we release the applied stress. How the stress and strain are quantifically proportional or related is known by a constant called modulus of elasticity, and it is also called Young's modulus. Its units are Pascal. If we try to give some formula related to Hooke's law of elasticity, it says that dl is equal to sigma upon E, where E stands for Young's modulus, sigma for applied stress, and dl for the strain that is actually produced after applying the stress. Okay, so this was about Hooke's law of elasticity, which is actually giving a correlation between stress and strain using a constant that is called Young's modulus. Moving forward, if we talk about Newton's law of viscosity, first we should understand the term viscosity. Viscosity is actually an inherent property of liquid material which they try to undergo once it undergo deformation. It can be irreversible deformation or permanent deformation, because unlike solids they are not able to get back to their original positions. So it is actually defined by Newton's law of flow. The what is the correlation between shear stress and shear strain? Like in the previous case, we have talked about the solids, which is defined by Hooke's law of elasticity. Similarly, Newton's law of viscosity defines such flow of viscous liquids, and a pure viscosity or pure viscous flow take place whenever continuous movement during the applied force takes place, and there is no restorative motion which takes place once the force is withdrawn. If we talk about viscosity, we must understand the term viscosity. To understand this, consider this particular cube shown in the figure, and consider there are two parallel planes at a distance delta y apart. The viscous body is confined between the planes. When the force F is applied, like shown here, at this particular place, if we are applying force in this particular direction, and this is the distance between these two planes, first plane is this and second plane is this particular plane will remain stationary once the force is applied in this particular direction. So after applying certain amount of force, the plane which was originally here will get shifted from here to this particular position. Similarly here. Fine. So a new plane will be developed, which is whose position is totally different from the original position. Somehow only the upper portion, or that this plane, is changing its shape, whereas the bottom plane is quite constant. So the two planes are there. One is, they are these are at a distance dx apart, and a viscous body is confined between these two planes. When force is applied at the top, plane A, upper plane, will move horizontally with a velocity dv, but the lower plane remains motionless. That means its velocity will be 0. As a consequence, among these two planes, there will be a gradient in the velocity which will be developed, that is dv, but the lower plane will be motionless as such. So this velocity gradient over a distance is known as the rate of shear. Sometimes we denote it by the letter d also. So that d is equal to dv upon dx. Dx is the distance between these two points, these two planes. So the horizontal force per unit area which is creating this particular deformation is known as shear stress, as defined here. So the horizontal force per unit area creating the deformation is known as shear stress. As per the Newton's law of viscous flow, whatever force per unit area we are applying will be directly proportional to the rate of shear it is creating. That means if I am applying more force in this particular direction, so that deformation will be more. So the distance, the difference between the velocity will be more. That means the gradient will be more. That means there will be more rate of shear. So shear stress is directly proportional to the rate of shear. And if we replace this proportionality constant, if we replace this proportionality constant alpha with equality term, then there is a constant which comes into picture, which is called viscosity or coefficient of viscosity. So this viscosity is nothing but an internal friction inside the fluid, that is resisting the motion of adjacent layer of liquid. If we talk about viscosity and determine or define it as on mathematical ground, so it is a tangential force per unit area, and its units are dynes per centimeter square, which are actually required so as to maintain a velocity gradient of 1 centimeter per second between two plane layers of liquid which are 1 centimeter apart. What does this statement mean? This statement means that if we have these two planes and they are and the force that we are applying is 1 centimeter per second, and this will displace the plane of the fluid up to 1 centimeter. Okay, the shear stress which is being used to produce a deformation of 1 centimeter per second is 1 dyne per centimeter square. If this is the case, then the viscosity will be the tangential force which is required per unit area in dyne per centimeter square, which is required to maintain a velocity distance of 1 centimeter per second between these two parallel layers of liquid that are 1 centimeter apart. Fine. So this is the definition of viscosity. If we talk about the units of viscosity, if we use the same equation, shear stress will be equal to shear rate, that is F by A will be equal to eta upon eta into dV by dx. So the rate of shear has a unit of per second. The unit of viscosity will be dynes per centimeter per second, because if we talk about eta here, so eta will become F by A upon dV by dx. So its unit are dynes per centimeter square, and dV by dx has a unit of per second. So it will be dynes per centimeter square per second, and that is called poise. So 1 poise will be that amount of tangential force per unit area which is required to maintain a velocity difference of 1 centimeter per second between two parallel layers of liquid which are 1 centimeter apart. So for dilute aqueous solutions, the common unit is centipoise somehow, and that is nothing but 0.01 centipoise. The viscosity of water is about 1 centipoise. If we talk about the SI unit, it is Pascal second, and the correlation between poise and Pascal second is that 1 Pascal second is equal to 10 poise. If we talk about these liquids, the absolute viscosity of some of the liquids is at 20 degrees Celsius in centipoise is for water, as I already told you, 1 exactly, it will be 1.0019. If we talk about ethanol, 40% liquid, then its viscosity will be 2.91 centipoise. If we talk about glycerine, 95% weight by weight, its absolute viscosity will be 545 as compared to water, which is almost 1. If we talk about castor oil, its viscosity is 1000. So it is much more viscous than water and any other solvent. So this was all about what is elasticity, what is the Newton's law of viscosity, and Hooke's law of elasticity. Hope you have understood this concept. I hope you like this video. Do click on the like button, subscribe my channel, and share it on social media. Get yourself educated, because education is the most powerful weapon which you can use to change the world, as per a famous quote of Nelson Mandela. So keep studying, keep yourself educated and alert. Thank you. Have a nice day.